Hey guys, this is Chapter 5, Section 8, Graphing Absolute Value Functions. And our learning objectives is to be able to graph an absolute value function from an equation or table of values, and to write an absolute value equation when you're given a graph or a description. So as we roll through this, let's talk about what an absolute value is. So an absolute value graph has a V-shaped graph that opens up or down. So let's draw a picture next to this. So if I had my X and Y axis, my absolute value would look like a V. And a translation is when you shift horizontally or vertically or both. So it's taking that same graph and moving it up or down or left or right. So when we're talking about functions, we have already talked about parent functions. And the parent function for absolute value graph is going to look like this. Well, let's first see what happens. -2, -1, 0, 1, and 2. And we are going to plug in these values and apply the absolute value. So I'm going to plug -2 into the absolute value. Absolute value of -2 is 2. So my coordinate that I'm going to graph is -2, comma 2, which is right here. And then I'm going to do the same thing with -1. We go ahead and put that in the absolute value. Absolute value of -1 is 1. So then we're graphing -1, comma 1. That is right here. We plug in 0. Thankfully, the absolute value of 0 is 0. And we graph the coordinate 0, comma 0. Absolute value of 1 is 1. Remember, absolute value means distance away from 0 on the number line. And 1, it does not make the value inside negative if that value is already positive. It just leaves it alone. So the next coordinate I'm going to graph is 1, comma 1. This is the upside of our V shape. Absolute value of 2 is equal to 2. And then we plot 2, comma 2. I'm going to go ahead and connect those coordinates. So the parent function is a V-shaped graph. It's got its corner, it's the little pointy part, is at 0, comma 0. So go ahead and pause real quick to make sure everybody's got this graph and the coordinate written down. All right, so we're going to look at translations here. So pictured are graphs of y equals absolute value of x, and if that's confusing, that's this guy, we just graphed it. And then this is y equals absolute value of x minus 2. So we want to take a look at how these graphs are different from each other. So we're going to list the differences here. I look and they both are V-shaped. They both increase and decrease at the same rate. The only difference is this here is at -2, and my corner here is at 0. So let's write that. The point of the B is at 0, 0 on the parent, and at 0, -2 for y equals absolute value of x minus 2. Okay, take a moment to pause this video and write down this information. So there is a direct relationship between being at 0, -2 and this absolute value of x minus 2. If that were a plus 3, so then it would be up here, the corner would be up here at 0, 3. So this corner here for our now you try is at 0, 4. So when it's asked how is the graph at the right related to the graph y equals absolute value of x, we're going to say it is moved up 4 units. The original parent function is down here, and then this one above is moved up 4 units. Everything else is the same. All right, we're going to take a look at that situation and how it applies to the equation of our graph. So if I have y equals absolute value of x plus 2, so if my original corner is at 0, 0, this one is going to be at 0, 2. So I'm going to go to 0, 2 and plot that point. And then it's going to V-shape up to the right and V-shape up into the left. Take a moment to check that all the students have this written down on their paper. All right, now you guys are going to take a second and do the same activity, but you are going to do it with this graph, this equation here. Y equals absolute value of x minus 6. So go ahead and pause the video for a moment and give students time to complete this problem. All right, so the answer to this one is, if my parent function is at 0, 0, and this one has to be instead at 0, -6. So that means my little corner is at 0, 6, and it increases to the right, and it increases to the left. And that's the graph of y equals absolute value of x minus 6. The horizontal translation is a little bit different. So let's go ahead and graph it and see how it's different from the up and down vertical translations. So we're going to take the graph of y equals absolute value of x minus 5, and we're going to take a peek at what this does when I plug in -1, 0, 1, 2, and 3. So I'm going to plug in -1. -1 plus 5 is 4. Absolute value of 4 is 4. I'm going to plug in -0 plus 5 is 5. And the absolute value of 5 is 5. Absolute value of 1 plus 5 is the same as the absolute value of 6, which is 6. Absolute value of 2 plus 5 is the absolute value of 7, and that is equal to 7. And absolute value of 3 plus 5 is the absolute value of 8, or just 8. So the coordinates I'm going to plot are -1, 4, 0, 5, 1, 6, 2, 7, if I have space for it, and 3, 8. So let's go over here to our graph. -1 up 4, over 0 up 5, over 1 up 6. Oh, nice. Okay, so I need to find out where the corner is, and all right now I'm doing is increasing this way. So we are going to go ahead and try a couple more negative values. So we're going to try -2, -3, -4, and -5. So the absolute value of -2 plus 5 is the absolute value of 3, which is 3. And then the absolute value of -3 plus 5 is the absolute value of 2, and that's 2. Absolute value of -4 plus 5 is the absolute value of 1, that's 1. So let me put those coordinates here, -2, comma 3, -3, comma 4, -4, comma, -2, comma 3, -3, comma 2, -4, comma 1, -5, comma 0, because the absolute value is -5 plus 5. And let's do -6 just to round the corner here. -6 plus 5. The absolute value of -1, which is 1. Let's go ahead and add those points to our graph, the ones in red. -2, comma 3, -3, comma 2, -4, comma 1, -5, comma 0, and -6, comma 1. So here is where the corner is. Corner is at -5, comma 0. The parent function the corner is at 0, 0 for the parent. So when we're taking a look at the graph of y equals x plus 5 and y equals absolute value of x, the corner changes from 0, 0 to 0, comma -5. Actually, switched. So the corner here is at 0. Corner here is at -5, comma 0, and the corner here is at 0, 0. So think about where that 5 is coming from, and let's go ahead and try that with this problem here. So I'm going to plug in like 1, 2, 3, 4, and 5. And we're going to take the absolute value of that and -4 from it. This is -3. And then take the absolute value. We do the same thing. 2 minus 4 is -2. And then I'm going to take the absolute value of that to get 2. Absolute value of 3 minus 4 is the absolute value of -1, which is 1. The next point is 3, comma 1. Absolute value of 4 minus 4 is the absolute value of 0, which is 0. And the absolute value of 5 minus 4 is the absolute value of 1, which is 1. So now I have all these coordinates to plot. So I'm going to go over 1 up 3, put a dot there, over 2 up 2, over 3 up 1, over 4 up 0, and over 5 up 1. So I can see that my corner happens right here at 4, 0. So let's take a peek. Y equals absolute value of x. Its corner is at 0, 0. And then y equals absolute value of x minus 4 has its corner at 4, 0. So what I can tell you is the 4 is not a coincidence, nor is the 5 a coincidence. And what I want to tell you, make sure we note, is that it's always opposite whatever sign it is inside those absolute values. So for this one, x plus 5, it happens at negative 5, 0. When it's x plus 4, sorry, it's x minus 4, it's at positive 4, 0. So it's always the opposite of what's inside the absolute value. Okay, go ahead and take a couple minutes, write your summary. It's 4 sentences with a capital at the beginning and a period at the end, and using the learning objectives to guide what you learned in this section.